what is measured improves. You might be familiar with this quote. Maybe you apply it to your own life. You step on the scale every now and then. You measure your runs on Strava, or you track your screen time. What is measured improves. This quote stems from a time of great excitement in science. It's attributed to Carl Pearson, the founding father of modern statistics. That's the field of mathematics that deals with making inferences from data. And this field emerged in the late 1800s, and I cannot stress enough how big of an impact it still has on our lives today. Now, the hero of our story, Carl Pearson, was an old school scientist, a discoverer, a true homo universalis. He would rush from science to philosophy, and then from philosophy to our old friends the poets, and then, overwearied by too much idealism, he would fancy himself becoming practical and return to science. Have you ever tried to conceive everything in the world worth knowing? That not one subject in the universe is unworthy of study? The giants of literature, the many mysteries of multidimensional space, the attempts of physicists to penetrate nature's very own laboratory itself. Those are his words, not mine. And at this time in science, not everything was so much based on empirical measurements. Of course, you had mathematicians and you had physicists busy with numbers, the laws of nature, trying to predict the motion of planets. But a field like psychology or biology was much more theory-based. It wasn't so much based in empirical measurement, it was based more in anecdotal evidence or the authority of scientists. And what Pearson did was, he set out to change this. I used to teach a statistics course, and in the first class I would always introduce the field of statistics a little bit through the history of science and Pearson's contributions to it. And in it I would always mention the following experiment. Pearson ran it in 1903. So, what he did, he went out into the London streets and he started measuring height specifically. He would go out and he would measure the height of a man, and then he would also measure the height of their father. And after he did this for a couple of days, he had collected samples of 1,000 men and their dads. And what he did with this data, as a good scientist, is that he would make a plot. So let's try and do that together. So on one axis, he put the height of the father, and on the other axis, he put the height of the son. And let's say that my dad, who's in here, 175, and I'm 178. And I'm 178, so we will be somewhere in the middle of this plot as a pair. And then let's say someone else is 190 and their son is 195, they would be up here somewhere. And a smaller pair, they would be somewhere here. And plotting out 1,000 of these points, he discovered a pattern in the data. The taller the father, the taller the son. And this pattern he called a correlation. And with this correlation, he could do something amazing. He could make predictions. If I measure my height, then by using this correlation, I can predict the height of my unborn son. And let's take a minute here to kind of realize what's happening, because this prediction of how tall my son will be is not based in any knowledge of biology, or I don't need to know anything about DNA. It's purely made based on empirical data. And, well, Pearson not only discovered correlation, but he made many other fundamental contributions to statistics, stuff that we still use today, like the histogram, kurtosis, the mode, principal component analysis. You can imagine that this guy is somewhat of a hero of mine. Well then, imagine my surprise finding out that he was also a physical anthropologist. What's this busy mathematician doing in a field like physical anthropology? What even is physical anthropology? Well, that's the field known as scientific racism today. As it turns out, Pearson's not really the hero of our story. He had a few skeletons in his closet. In fact, he had 7,000 skulls in his closet. See, the statisticians at the time, they lost themselves in all this excitement about being able to predict the future. They started measuring, improving. They lost themselves in empirical madness. measuring and improving humanity itself. Eugenicists at the time started categorizing humans into races, deciding who was superior and who was unfit to breed. It only took a couple of decades to go from discovering something really exciting like the predictive power of the mean or the variance of the distribution to predicting race from human skulls and bones. The statisticians at the time thought that measuring the circumference of your skull could predict your intelligence, or that the size of your nose decides whether you would be a criminal or not. Now, for about 30 years, we've settled the academic debate. We know that human race is not a biological thing. In fact, any arbitrary group or race you might define, the variance within that group will always be larger than the variance between those groups that you define. But all the excitement at the time led to some dark, dark history. It was a time where empirical data and correlation overtook sound scientific reasoning and causation. And now today again, we find ourselves at a time of great excitement, a rediscovery of the predictive power of data. A time again where we try to predict fraud based upon the numbers that we are made up of, where all the data around us is compressed and rejumbled into the AI slop that's living in our brains rent-free. A time where we decide who to hire or what products to buy and let that decision be handled by a machine. A time even where transhumanists conjecture that machines might replace humanity itself. Now, all these big AI systems that we're also hyped up about, they're not based in sound scientific modeling of a system. They're not based in reasoning. They're based in predictive statistics. They're correlation machines. What that means for our future, I do not dare to predict.